So in the last episode, we concentrated on the repair effect that SMS cells could have on the lung of patients that are affected by COVID-19, based on experimentation that were done in vitro and the stimulation of alveolar type 2 cells. What I would like to discuss today with Dr. Roger Schechter, who is a specialist in emergency medicine, is the potential for other organ treatments. And can you tell us, Dr. Roger, more about these other organs and their situation within COVID-19 seriously or critically ill patients?
Well, as we discussed before, Dr. Rahmo, there are other organ systems involved. Patients' central nervous system, possibly the peripheral nervous system, the cardiac system, peripheral circulation, liver, kidneys, can all have effects from COVID-19 and may undergo some end organ damage, possibly from microclots and possibly from the effects of the virus itself.
Yeah, this is, I think that issue is really a challenge. I mean, when you treat patients and you see multi-organ failure or several organs being compromised, it's extremely hard to treat the patients and to even instigate an intelligent treatment. So the questions really is there a way of addressing these several problems with one agent and something that unifies all these problems and all these challenges to the tissue? And we know that it's not just the virus, it's also the immune system that is affecting these dire consequences on the organs. Now, we know that from prior discussions that SMS cells have an effect on mesenchymal stem cells. We know also that mesenchymal stem cells are present in all organs that are vascularized, and these are most organs, with very few exceptions to that. So if SMS cells have the ability to stimulate the proliferation and the functionality of these cells, then you might see a systemic effect of these SMS cells inside the body of patients, and SMS cells could have an effect on the repair aspects of several organs, including those that are being compromised by this disease. So I think it's a possibility that should be addressed and researched.
Absolutely. Another point is that SMS cells, being native to the circulation, that if they are injected in higher quantities than are currently present, they will be able to move about pelagically in the blood and be at any of those solid vascularized organs within 2 to 3 minutes of injection.
Yeah, I think that's an important point. We had seen challenges with regard to application of mesenchymal stem cells to the intravascular system. We've seen these cells dying within 24 to 48 hours. So I expect that SMS cells with their sturdy, robust constitution, their small size, their less likelihood of clumping and adhering to each other, their being very naive in terms of immunogenicity, I see them to be much easily administered and addressing these organs than using the mesenchymal stem cells. So instead of administering mesenchymal stem cells like we have seen many approaches right now, many attempts to do that with some success with regard to COVID-19, we would be addressing mesenchymal stem cells that are endogenous inside the body using the stimulation by SMS cells. Is that a plausible approach, Dr. Roger?
Well, yes, it is a significantly plausible approach that through an indirect effect, the SMS can exert an immunomodulatory effect because of their effects on the mesenchymal stem cells. Beyond that, with respect to other organs that may be damaged by COVID-19 or other devastating viral illnesses and other systemic conditions, including sepsis, SMS may also stimulate direct repair of the cells, as is the model in the lung, where you're stimulating proliferation of a cell type and its differentiation into another cell type in order to bring about regeneration. That could easily occur with the liver, with hepatocytes. It could happen with renal cells. It could happen with nervous system tissue. So that needs to be explored. But again, that may be the future for regeneration, which would be to have this ubiquitous cell put in quantity into the circulation and have it bring about a multi-organ system repair.
Yeah, I think that's quite interesting. There is no proof yet in vitro that we have an ostensible effect on liver cells or kidney cells. But this might be definitely possible, and it may not show in vitro, it may show only in vivo, because the situation is so different.
Yes.
But I think there is also a paradigm here, is that we are not trying to use cells that are genetically modified, that are very different from what is existing in nature. So SMS cells are native cells, and although they have been grown in the lab, but they do not include any genetic modifications like it would be the case with an induced pluripotent stem cells. They are not taken from an embryonic tissue, so that they would be chronically misplaced. That means taking cells from a different stage of human development and putting it in the adult stage of development. No, these cells are isolated from adult human blood, and they are grown within specific conditions, and they are quite resilient. Therefore, they maintain their native states to large degree. So I think this is the paradigm where we want to enhance the ability of the body to repair itself without going into extremes that may harbor other dangers and may pose a risk to the body, such as we see when we introduce embryonic stem cells or genetically modified cells.
So a question I have you characterized what the, through cytometry, what the average or normal range of concentration of small mobile stem cells would be per milliliter of blood?
Yeah, we have estimates on the amount of SMS cells in adult blood, and these numbers are proprietary still. However, it is, I think, also something that we look forward to test. What are the variations within the populations with regard to the quantity of these cells within the blood? Does that reflect on their ability to repair and regenerate tissues? These are important questions. Unfortunately, they require serious funding because you would be looking at a large population. And this is something we have not done, but we're looking forward to do at some point in the future.
Well, a suggestion.
Go ahead.
A less expensive way to do this would be, rather than drawing people's blood, but actually engaging blood banks in the study, because blood banks in general will take blood from a healthy population, and as long as you have whole blood, in order that you can do appropriate quantitation, just a very, all you need is a milliliter of whole blood in order to do your cytometry. It shouldn't be as expensive a study as you're anticipating, because you can engage blood banks in this and likely obtain grants in order to do that. Beyond that, blood is drawn frequently from people who have sepsis, viremia, viral sepsis, and you have, again, a ready source of non-healthy blood in order to determine if there is relative cytopenia of SMS cells versus what's found in healthy whole blood, because that would be very interesting to find out, considering that the hypothesis is that by infusing SMS cells in quantity, you would bring about regeneration and cellular repair. And again, in treating disease states, it would be interesting to see if there is a paucity of SMS cells in diseased blood.
Yeah, I mean, there are two assumptions here that we have to take care of. The first assumption here is we have to prove that between drawing blood and blood bank, there is nothing happening to the SMS cells in terms of numbers and in terms what allows us to assess them quantitatively accurately. The second assumption is about the fact that quantity of SMS cells is a relevant parameter regarding treatment or regarding the repair, the endogenous repair within the body. Now, we still have to prove that quantity is a key factor here with regard to SMS cells. There could be also quality-driven aspects,
Sure.
something that stimulates these cells. We have some hints and indications that some stimulation is required for the cells, and that the process of proliferating the SMS cells invokes some stimulation that could be important for exercising these effects. But it is still open to research, and it could be a combination of two factors, of course, quantity and quality.
Makes sense.
So this is, I think, where we would like to conclude this episode time-wise, and we still have a lot to talk about with regard to SMS cells and COVID-19, and I would like to address that in the next episode. Thank you very much for watching, and foremost, thank you very much, Dr. Roger, for speaking to me and discussing these important items.
A pleasure.